absolute value inequalities with greater in them. So again, talking about absolute value inequalities, we're going to change that absolute value inequality to a compound inequality. We're going to take our original inequality and we're going to work with this equation, solve the absolute value of 3y minus 3 is greater than 9, and then graph the solution set. So we want to make sure that the absolute value symbols are alone on one side. So if I'm multiplying or dividing or adding or subtracting anything, I want to get rid of those first. So I have the absolute value symbols isolated. We're going to break this up into what's inside the absolute value symbols is greater than 9. We're going to keep it the way it is. But then we're also going to rewrite this as what's inside the absolute value symbols, 3y minus 3, is we're going to change this from greater than to less than, and we're going to change this from positive 9 to negative 9. So we want one inequality written basically with the same pattern that's there in the original, and then a second one that switches the inequality symbol and changes the sign of the expression on the other side of the symbol. All right, from here we solve like we would normally work with our inequalities. Again, notice I haven't put an and or an or here, even though I know it's a compound inequality. So once I have my two solutions that I'm going to work with, I'm going to take a look at my number line, and I know that these are my boundaries. So I've split these up as my boundaries. I know that I have a negative 2 as one of my boundaries, and I know that I have 4 as my other boundary. I'm going to check each of the sections on this number line to see what actually works. So I'm going to check something down here, less than negative 2. I'm going to check negative 10, and negative 10 works. So I know that on my number line, I can graph to the left. I'm going to check 0, something in the middle, and 0 does not work, so I know I'm going to leave this middle section of this number line empty. And I'm going to check 10, something larger than my 4, and when I check out a 10, I find that that works. So that's telling me that things to the right here will work too, so my number line looks like that. Hopefully you're recognizing that at this point. This is definitely a union of two sets, and a union of two sets is an OR. So this is an OR, a combination of these two. We are putting these two sets together, including all of the values in both sets, and coming up with a union. So my final solution for this in set notation will be y such that y is, we can write it either way, I tend to do the least one first, y is less than negative 2, or y is greater than 4. Remember, with an OR, we can't combine it into one kind of multi-part inequality. I have to write it out as two separate pieces. So my number line looks like this, and my set notation, compound inequality, looks like that. All right, so that was our OR. We're working with greater there. All right, let's try a couple more. Let's solve negative 11 is less than or equal to the absolute value of b plus 6. So again, I'm going to split this up into two. My absolute value symbols are already by themselves. They're isolated, so I can just move into writing this out as a compound inequality. One, I'm going to keep the pattern of the original. The other one, I'm going to change the sign of the expression on the other side, so I make that negative 11 positive 11, and I'm going to change this less than, I'm going to reverse it so that it becomes greater than or equal to. I'm going to solve each part of this, and now I see my boundaries here. Negative 17 is a boundary, and 5 is a boundary. I've gotten really lazy with my graphs here at this point. Let's check and see which parts of these actually are solutions for our absolute value inequality. Remember, I'm always going back at this point and working with my original absolute value inequality. So I'm going to check a number less than negative 17. I tried negative 20, and negative 20 works. So I know I've got numbers to the left of negative 17 working for me. I tried 0 in the middle here, and 0 worked. So I've got at least two parts of this working. And I checked a 10. 10 also worked. So I have my numbers to the right working here. And now I just realized that everything on this number line has been graphed. So we're going to write our solution set as, what did we use? B such that B is a real number. And this is how we write this out. We don't write all real numbers anymore. We write it out this way. B such that B is a real number. So if you pick any real number, it's going to work. So let's go back and look at why. Why is we getting this crazy, you can pick anything you want solution for this? So this is saying that negative 11 is less than my absolute value. If remember, our absolute value is always a non-negative number. It's typically positive or 0 is what we're going to end up with. This is telling me that negative 11 is less than or equal to any non-negative number. Well, of course negative 11 is less than or equal to any non-negative. It's never actually going to be equal to it, but it's going to be less than. So no matter what I put in here, this will be true. which is why we're coming up with b is a real number. So any solution, any number that you pick will work for that. So again, checking it to make sure that what you get there makes sense. Again, there is a pattern to my greater than or less than, my less than symbols there. So if you found a pattern, let me know. See if you can come up with it. We'll talk about that in class. All right, last little piece. Write an open sentence involving absolute value for each graph. Open sentence just means that there's a variable in it. That's all we're talking about when we talk about an open sentence. So we've been given this number line here with a graph. If you remember, our absolute value is talking about the distance from a midpoint. So I want to take a look at my number line, and I want to find the middle of my boundaries here. So I've got negative 10 and 2. Negative 4 is directly in the middle of those two boundaries. So I'm going to start my absolute value as the absolute value of x minus, in this case, negative 4. I'm going to find the distance between those. So the distance between negative 10 and negative 4 is 6. Between negative 4 and 2 is 6. So my 6 goes on my other side here. And then these distances are less than 6. So this has a distance of 2, this has a distance of 4. So I'm talking about distances that are less than 6. So my final absolute value inequality looks like the absolute value of, I'm going to simplify this, plus 4 is less than 6. Let's take a look at one more that looks a little bit different. So here we have our boundaries, and we have our number lines, our lines going to the middle. Our solutions are towards the middle. Our solutions are graphed to the outside, to the left and to the right. So again, I want to find the middle, the midpoint between my boundaries. So here's my negative 2 and 4. What's in the middle is a 1. So I'm going to do my x minus 1 inside my absolute value symbols. And then I'm going to find how far each of these midpoints is from the 1, and they are 3. I've got a distance of 3 there. When I go to figure out what is going to go here, because it's not going to be equal to, since it's an open circle, I realize that these distances are larger than 3. I have distances of 4, 5, 6, but these are distances that are less than 3 that are not included. So my inequality needs to be a greater than there. And you'll also notice this would definitely be an or. If I wrote it as a compound inequality, which is not what they're asking me for, this would be an and. This would be an intersection if I was writing it as a compound inequality. So continuing through our absolute value, talking about the distance away from a midpoint, making sure that our absolute value symbols are isolated before we split it up into 2, making sure that we write it one way, mirroring what we already have, and a second way, changing the sign of the expression on the other side, and changing that inequality before we solve, realizing that we're making this number line split into segments, and we're deciding which of those segments are actually solutions before we come up with our final solution for this absolute value.